Welcome back to Train Signal's VMware vSphere 5 training. You're watching Implementing High Availability with VMware HA lesson. Okay, so we've built this incredibly great environment. Well, now we have to secure it. But when I mean by secure it here, isn't secure it against hacking or secure it from a firewall perspective or any of that good stuff. I'm talking about secure it in ensuring the highest levels of availability for my virtual machines. Now, the promise of virtualization wasn't just so I can consolidate my physical machines onto less physical machines and take advantage of how to maximize the physical resources. The promise of virtualization is that I can do things different. I can do things better. I can recover from downtime. I don't want to have to wait when a server goes down 4 hours because I'm on a 4-hour response until a hard drive or a motherboard is shipped, so I can replace the failed part and then bring the server back up. I want to be able to recover in minutes. We live in fast times. I can't afford the luxury of hours of downtime. I need to be able to know that if if my VMs, if my servers are going to fail, I can recover these systems within minutes. So that's what we're going to do. We're going to talk about why do I need HA. So these are the things we're going to focus on in this lesson. Some of the HA love, some of the goodness in HA, how HA is going to save the day. We're going to talk about the master-slave relationship in HA. And the reason I mentioned that here is because prior to VMware vSphere 5, the architecture of HA was different. We had more primary servers and secondary servers. With vSphere 5 and on, the HA architecture has changed into one master server. One of the ESXi hosts in the clusters is going to become the master. All of the remaining hosts will be slaves, and we're going to talk about that master-slave relationship. We're going to talk about the requirements for VMHA. What do you need to do to make sure you have a proper VMHA configuration? And then we'll wrap up the lesson with best practices for VMHA. Let's go ahead and get started. So, why do you need high availability? Well, because I want to be able to quickly bring back critical business applications in the event that an ESXi host should fail. Now keep this in mind. We are now consolidating several different systems on one system. So technically we've created in some way, shape or form centralized or higher points of failure, if I can say so. So without high availability, what happens is, let's say you have a 10-to-1 consolidation ratio, which is low, I know, but let's just take that into account for a second. Well, now you've just consolidated 10 systems that were previously 10 separate isolated systems onto one. So you've increased your likelihood of a failure, and in the event of a failure, you now have 10 systems that are down, 10 systems that might be providing critical business applications that are down. High availability exists to avoid that. Now, in the event that an ESXi host should go down, the VMs that are on that host will go down. But the trick with high availability is how quickly can I spin them back up? How quickly can I return them back into service? So that's the whole idea behind having high availability. You add your ESXi hosts in a cluster, and then you manage the groups and their resources in a cluster manner so that when one ESXi host fails, the VMs that are on that particular ESXi host are going to be restarted on the remaining hosts within the cluster, and you restore that business application back to productivity into production within a matter of minutes. So it decreases downtime and improves availability significantly. And some of the examples of these business critical applications can be Exchange for mail, it can be SQL servers for data stores, it could be a combination of any of them. It could be SharePoint, file servers, internet, web servers, whatever the case might be. VMware high availability is saving the day. So how does this work, right? So let's say that you have an ESXi server hardware failure. Say maybe a bad CPU, maybe a bad motherboard, maybe a combination of both, right? Maybe just a network cable was yanked out of the back of the ESX host. For whatever reason, you lost the host, and that host has virtual machines that are running on it. VMware HA will power on the virtual machines that were running on the failed host on the remaining ESXi hosts in the cluster. High availability will monitor not only the ESXi for host failures, but also the guest operating system for host failures. So not only is it going to monitor ESXi and determine, hey, that host is failing from a physical perspective, you can also configure it, and we'll go through that, to monitor the VMs themselves. So if for example, we're not receiving a heartbeat from the VMware tools that is installed on the operating system, then that VM is having an issue and you can take immediate corrective action against it. One of the things that you can set it to reboot if you're not receiving a heartbeat, in the hopes that you can address the problem. Now you can also do smart failovers to the best ESXi host. That requires DRS, Distributed Resource Scheduler, and that plays in a number of ways, right? So you can configure it so that there's something called initial placement, and I'm sure David's going to cover this in the DRS lesson. With initial placement, as soon as the VM is powered on, it's going to be placed on the most suitable ESXi host based on the available resources of the ESXi hosts in the cluster. Now, DRS will continuously load balance the VMs across the most suitable ESXi hosts within the cluster. So there's a lot of benefits of also using DRS in conjunction with HA. Sometimes if DRS is detecting, for example, there's high latency, or if it can detect a failure on the ESXi host quick enough, it can move the VMs off of that ESXi host. You can have support for up to 32 ESXi servers within a cluster. And that being said, the number that I'm giving you now, for those of you that are going to be taking the VCP5 exam, these numbers can change. Maybe VMware, releases update 1 for vSphere 5. Just double check that this particular value is still valid when update 1 comes out before you take the exam, just in case there's been a change and we haven't been able to update it yet within the video. So keep that in mind if you're taking the exam. Enhanced isolation response, we're going to talk about what happens when a particular ESXi host becomes isolated. There is no network connectivity, there is no connectivity whatsoever to it. What can we do in response for that isolation of the host? Alright, so let's talk about VMware High Availability Master-Slave relationship. Well, first of all, the correct name for the master isn't master. It's called the Fault Domain Manager Master, otherwise known as FDMS. So it's important that you know this name. It's important that you memorize this name. It's important that you use this name. First of all, because I want you to sound like an expert. Second of all, because if it comes up on the exam, I want to make sure that you know what it's referring to. So don't get into the habit of using master, because then they're going to throw at you the Fault Domain Manager Master, and you're going to be like, well, what's that? Or it's going to confuse you. So I don't want that to confuse you. That's one. Two, you should note that there's only one master host per cluster. One server is going to become the master host. Everybody else is going to be the slave. Now that master, that FDMS, is going to be determined via an election. Now, considering I'm in Chicago, we are used to rigging the elections here. So there are ways of tricking it so that you can determine which host becomes the master. Now, typically, the host that has visibility to the most data stores is going to have the best chances of becoming the master. Every time a host reboots, a master election takes place again. If you put a host in maintenance mode, take it out of maintenance mode. Anytime there's a compelling event in the cluster, an election is held among the different ESXi hosts in the cluster, and one of them is elected as a master. Now, some of the functions, some of the duties of the FDMS is that it's going to monitor the state of all the slave hosts within the cluster. It's going to monitor the state of all of the protected virtual machines in the cluster. So the virtual machines that are configured for protection with HA, those are also going to be monitored by the FDMS. It's going to manage the list of cluster hosts and protected VMs. It's also going to act as Virtual Center's management interface into the cluster's health state. So what happens is Virtual Center, instead of contacting all of the slaves and say, hey, what's up, what's up, what's up, it's going to contact only the master. The master becomes its interface. Anytime it wants to know anything that's going on in the cluster's health, it contacts the FDMS master, and that communicates back to it on what's going on. Now, it's very important to know that, and this is a new enhancement with vSphere 5, VMware High Availability now checks for host failure not only using the management network. This was how it would check for it with vSphere 4 and earlier. It would check through the management network. If it doesn't detect a connection through the management network, specifically through the default gateway on the management network, then it would determine that that particular host has failed, and it would initiate VMware High Availability. vSphere 5 got a little smarter. It's not only checking the management network. So if the management network isn't responding, that default gateway isn't responding for whatever reason, it's also going to check the data stores. It's going to check via the data store heartbeat to make sure, is this host really, did this host really fail or not? So sometimes the management network might be down, but the host might still be up and the VMs might be serviced. We don't want to declare that the host is down. So with vSphere 5, HA became a lot more smarter. All right, so what are the requirements for VMware HA? So some of these requirements are probably given, you probably know them, but we're going to go through them anyway. You obviously want to make sure you have shared storage for VMs that are running in HA cluster. So all the ESXi hosts in the cluster have to have access to all the shared storage in order to be able to power on the VMs. So if you have an ESX1 and ESX2 and they don't have shared storage and there's VMs living on each, well, if that VM power goes down, ESX2 or the remaining or the surviving host can't power it on because it can't see its storage. So it's very important that shared storage be accessible by all ESXi hosts in the cluster. It's equally as important for all the ESXi hosts to also have access to all the VM networks across all the hosts. So make sure if you're configuring VLANs on some hosts that those same VLANs are accessible on other hosts for vMotion purposes first, but for VMHA purposes as well. You can use DRS in conjunction with VMHA, or you can just use VMHA in a cluster, as I'm going to show you in a little bit when we log on to Virtual Center. All hosts must be licensed for VMware HA. So make sure you're checking the licensing edition that you're using and that it supports VMware HA before you can enable that and it works properly. You obviously have to create a VMHA enabled cluster, and we're going to go through that in a second. All hosts must have a static IP address. Again, kind of a given, but I just wanted you to know. At least 2 hosts in the cluster, again, kind of a given. There's no point to a cluster if it's going to be single hosted. And at least 1 management network. Best practice says 2. Hey, instead of having just 1 management network interface, 1 access into the server, if you can create a redundant one, then that calls for best practice. It makes it a little easier and it enhances VMHA. Now, obviously, if both management networks have the same gateway, well, then, from an HA perspective, it doesn't help very much, and that's why I'm going to show you in the best practices how we can have HA check with a different IP address rather than just the default gateway. All right, best practices for VMHA. Well, first, keep an eye on the cluster validity. You always want to make sure that the cluster is healthy, it's valid, no errors, so on and so forth. Basic stuff. It's very recommended that you disable host monitoring as you make changes to your network or DV switches. Now, why is that? Now, host monitoring is a feature that is configured by nature to check for network connectivity, right? So it's checking for that heartbeat. If you're making these network changes and the management network on the ESXi host is losing connectivity, host monitoring is going to try to declare the ESXi host as inaccessible and isolated. Now, granted, with vSphere 5, it'll still check through the data stores, but for best practices, for stability reasons, if you're going to make any kind of changes to the network, especially the physical network in this matter, I suggest, or we suggest, that you disable host monitoring. All networks and VMs on HA clusters must have compatible networks. This just means that make sure that all the ESXi hosts in the cluster have access to all the VM networks. By default, network isolation IP is the default gateway. That's what I've been telling you. But I'm going to show you as we get into the GUI how you can configure a different IP address by using the advanced values in here. And I've highlighted the particular value. I'm going to show you where you can go in to VMHA and change it. So the X here in this particular value means that you can say you can go from 1 to 10, so you can have up to 10 additional IP addresses, and every one of those values here, 1 would equal an IP address, 2, etc. And I'll show you how to do that. Use network redundancy between ESXi servers, so basically make sure you have more than 1 management network, so on and so forth. All right, enough slideware. Let's go ahead, jump into vCenter, and let's configure VMware High Availability. From the home screen of vCenter, what we're going to do is select Hosts and Clusters. Again, we're configuring a cluster, so this is the view that we want to be in. Now, I already have a cluster configured, right? HA DRS cluster, but I don't have any features or functions into this cluster yet. So what I want to do in order to configure it is I want to right-click it, and I want to drag down to where it says Edit Settings. Now, within Edit Settings, if you wanted to change the name of your cluster, you have an opportunity to do so here. Otherwise, you can check what type of cluster you want to create. Do you want to turn on vSphere HA for this cluster, or do you want to turn on vSphere DRS for this cluster, or do you want to turn both of them on? For the purposes of our lesson, we're going to go ahead and just turn on vSphere HA. Once you turn it on, then you'll see that you have access to additional options on the left. Let's start with vSphere HA here. The first thing that we have here is enable host monitoring. As we talked about during the lecture, enabling host monitoring allows the HA cluster to continuously monitor the ESXi hosts within the cluster for heartbeat. If it doesn't receive that particular heartbeat, then it's going to deem the ESXi host in isolation. So this is how you enable monitoring. And again, if you're doing changes to your physical or virtual network for that perspective, I recommend that you come into HA and immediately uncheck this box, make your changes. Whenever you're done, when the network is stable and it's ready, you check it back up. Now, admission control. You have two options here. If you set it to enable, then what happens is the VMs that, in the event of a failure of one of the ESXi hosts, if there isn't enough resources in the cluster to power on the VMs, then it won't power them on. So what you're seeing here is disallow VM power on operations that violate availability constraints, which means you're not allowing for any kind of overcommitment at the CPU, at the memory level. If there isn't enough resources, I don't want you to power it on. The second option here, which is disable of admission control, means you allow the virtual machines to power on even if they violate availability constraints, which means you're immediately starting to overcommit, whether it's memory or other resources. You're probably going to swap, whatever the case might be, but you're allowing those VMs to power on even though they violate the availability constraints, because those VMs might be important, they're critical, they have to come up. So that's when you would come in and enable that. Best practices, if you can get away with it, if you've done your homework and you've configured your environment properly, this should always be set to enable. I'm going to give you some advice, and we're going to talk about it here in this section of the admission control, because this controls based on what you have here. So let's talk about that for a second before I give you some advice here. You have a couple of different ways of reserving resources so that in the event of a failure, you have these resources, right? So the way you're configuring your cluster now is I'm willing to accept one host failure in my cluster. I want to reserve enough resources so that I can withstand one host failure. That's one option of doing it. So what you're saying here is if you're enabling this, which means you're not going to allow it to power on any VMs. So if you have more than one host failure, that's going to create more VMs than what the cluster can handle. Do you want to allow those virtual machines to get powered on within the cluster, even though they violate the availability constraints, which means the cluster is ready for one host, but we've experienced two host failures. So what do you want me to do in this case? So again, depending on how you've configured the cluster, right? The other option down here is you can configure the availability of the resources in the cluster based on a percentage, which is what I like. I think the first one was kind of a lot more, ESX 2.5, ESX 3, 3.5 days. But vSphere 5, I would rather take a percentage of all of the cluster's resources rather than say just one, I will tolerate one ESX failure. So in this case, you're saying if you're disallowing it, if the availability constraints violate 25%, then you don't power them on. So this is how these two kind of tie together. Now, that being said, here's some best practice. You should always, always, always reserve 20 to 25% of the resources of a particular host for HA. So let's say with vSphere 5, you're trying to design for licensing, and you've made up your mind that you're going to have 92 gig of memory in every one of your ESX hosts, and those 92 gig of memory are going to be deployed. They're going to be used by virtual machines. Then I would automatically recommend that you put 128 gig of memory in that particular ESX host. So the difference between 96 and 128, that is left for HA. That is memory that you're not supposed to allocate to any virtual machine. You're not paying for it from a VRAM perspective or anything like that, but it's available in the event of a failure, then you can use it. So always, always, always plan for about 25% per host in your cluster from a resources perspective across the board, whether it's CPU, storage, memory, whatever the case might be. Now moving on here, this is what I typically like to configure. And again, you can configure 25% of the CPU and 25% of the memory, or you can change these particular values. The other option is you can specify a failover host. Now this one I don't like at all. So what you're doing here is you're saying that, look, I'm going to have one ESXi host, ready, licensed, memory, everything's in it, but I'm not gonna use it. It's just gonna sit there idle, waiting for a failure to happen. So my problem with that, and even though I'm sure someone has found a real business case to use it, my problem with that is, look, we're doing virtualization in the first place to avoid these resources that are sitting there idle. Why would I put a host in idle, sitting there doing nothing, consuming a license, taking up, well, it's not really consuming a license, because if it takes the place of a failed host, then the licenses would go over to this one that's in standby. But the memory and CPU are just sitting there doing nothing. Why don't I just put them in the cluster and use the percentage here to just level set everything, to load balance everything, instead of having hardware that's sitting there doing nothing? Now, in the event that you found some kind of a use case, you can select it, and you can go into choosing the particular host that you want to make as a standby host. So you can click to add here, and you can go through and you can select which host that you want to add as your standby host. Now, you click on the advanced options down here. This is where you can configure advanced values for HA. Now, remember when we were talking during the lecture, I told you that by default, VMHA will always check, or will always try to ping the management network's gateway for heartbeat. So that's how it determines if an ESXi host is up or down. Now, if you think that the default gateway isn't a reliable IP address and you want it to provide a different IP address, or if you want it to provide multiple IP addresses that HA should check with, then you should use the option that I had in the lecture as well, which was this. And towards the end, you want to put a numerical value of 1. Now, you can have up to 10 of those. Now, in the value here, you can specify the IP address that you want that is more reliable in your case, for example, or in your opinion, for HA to use. So it overrides the default of the default gateway or the management network, and it uses this particular IP address. Now, you can, again, add up to 10 IP addresses. I don't recommend you go very high with the number of IP addresses, because that will slow things down. The response time becomes slower. So maybe 1 or 2 should be more than enough. But again, this is where you can come in to do that sort of stuff. I'm going to click on cancel here. I'm going to set this back to my 25%, and then let's go into virtual machine options. Now, with virtual machine options, you are determining what happens to the virtual machines in the event of a host failure. Which ones come up first? Which ones have higher priority than others? Keep in mind that the settings that we have up here, those are cluster-wide settings. Those apply for all of the virtual machines. Now, you'll see in a second that I can configure those on a per virtual machine basis, which means I can override the cluster-wide settings. However, from a cluster perspective, if the host is in isolation, your response to it is what? If we figure out that a host has been isolated, do you want me to leave the VMs on that particular host powered on? Or some of the options that you have is, hey, I want you to power off the VMs. I want you to shut down the VMs. What do you want me to do? Power off is just like yanking the cable. Shut down is more of a graceful shutdown. Now, from a VM restart priority perspective, you're setting the restart priority on all of the VMs in the cluster to medium. So that means if a particular host fails, all of the VMs on that particular host are of equal restart priority. They're all the same type of importance. That I would change for sure. So based on the VMs, you should evaluate the different VMs that you have. For example, my vCenter server. Well, I want to make sure that, first of all, from a VM restart priority, it is high. It is very high. It is as high as possible, right? So I want to set this to high. You can use the cluster settings. You can disable it if you want, but I want to set it to high because I want to make sure that in the event of a host failure, if vCenter is on that host, I want it to come up as quickly as possible. From a host isolation perspective, what do you want to do for this particular virtual machine? Well, for this particular virtual machine, if the ESXi host goes into isolation, well, maybe I just want to shut it down so that HA immediately kicks in and it's restarted on a different host. So again, these are the different options that you can change here in order to respond to ESXi host failure at the virtual machine level. Now, if we move on to VM monitoring, VM monitoring is disabled by default. What happens with VM monitoring is the same way as the host isolation or the host monitoring monitors the host via a heartbeat. The VM monitoring monitors the VMs via a heartbeat as well, and that heartbeat is provided by VMware tools. So VMware tools would have to be installed on the VM in order for this to work. And the way it works is if it doesn't receive a heartbeat back from that particular virtual machine, then it deems that virtual machine as down or failed or whatever the case might be, and it takes corrective action against it. So if you wanted to enable it, again, it's pretty straightforward on how to enable it. You can do VM monitoring only, or you can do VM and application monitoring. Again, they're pretty self-explanatory if you have vApps and all that good stuff. For me, I'm just going to enable VM monitoring only for now. And then you can modify the monitoring sensitivity. How often do you want it to monitor, so on and so forth. Right now it's set to high. You can most certainly customize it and then pretty much, give it a failure interval, a minimum uptime, etc., etc. These are just intervals that you put here from a threshold perspective that allows you to more accurately and more closely monitor how you want those VMs to be monitored by the cluster. Now again, if you wanted to override the cluster settings at the VM level, then again you can come here and you can select the VM itself, and from the drop-down menu you have several different options that you can configure at the VM level to override the settings that you're creating up here. Alright, let's move on to data store heartbeating. Now, remember in the lecture we talked about the fact that with vSphere 5, HA will not only just monitor the management network for host failures, it's also going to monitor the data stores for heartbeats so that it can determine if the host has truly failed or not. So there's different layers, different level of monitoring to ensure that that particular host has failed. And this is where the data store heartbeating comes into play. You can come in here and specify which data stores you want to participate in the data store heartbeating, and you have several different options. You can select only from my preferred data stores or any of the cluster's data stores, and then you can select any of the cluster's data stores taking into account my preferences. So again, you have the option here of tweaking it. So for example, if this was your preference to have this iSCSI data store, then you would just pretty much select it, and this becomes one of your preference. Now depending on the options here, you can either always use this, or you can have it take into account your opinion but not necessarily abide by your opinion, so to speak. So again, this is how you would come in and configure that particular setting. And that's all there is to it from a VM high availability perspective. I'm going to go ahead and click on OK here, and let's go ahead and switch back to our presentation and recap what we've learned. I gotta give it to you, for those of you that are virtualization veterans and that know about HA and they're just watching these videos as a refresher or to know what's new, or just to have it on the shelf for administrative purposes, good for you, right? But for those of you that are watching it for the first time and learning about VMHA, it just reminds me of when I first saw it, when I first sat into that classroom and I was starting to learn about HA, and I'm like, wow, this is pretty cool stuff, and I got attached to it right away. I remember going back that day and I started eating the books, eating the documentation, anything I can find about the stuff because it was so exciting. And now HA is just so easy, but after you've seen it work, and I've been doing this for like 7 or 8 years now with VMware since its early stages, appreciating the value of HA and some of the things that VMware brings to the table, that'll only come up, you'll only appreciate that truly in the event of these issues that will come up. It's inevitable that issues are going to come up during your career, but that's when you're really going to appreciate HA and some of the other features. So what did we cover? We started off by talking, well, why do you need high availability? We talked about the fact that you've built this great environment, but now you have to be able to protect it, to provide highest level of availability for your virtual machines, so that in the event of a failure of a host, hardware failure, software failure, corruption, whatever it is, you can restart the virtual machines on the remaining ESXi hosts in the cluster. We talked about how VMHA is going to save the day, how it's going to isolate the ESXi host, how it's going to reboot and restart the virtual machines, the priorities, the isolation, so on and so forth. We discussed the master-slave relationship and the fact that with vSphere 5, HA has been completely re-architected and that there's no more primary and secondary hosts. There's one single master host in the cluster. Everything else is a slave, and that master host is determined via an election. We also discussed the fact that with VMHA in the new architecture, there's two ways of determining a host failure. There's the traditional way through the network management, pinging the default gateway, and then there's the heartbeat of the data through the data store to make sure that that host is up or not. We then discussed the different requirements that you need for VMHA, and we wrapped up the lesson by talking about best practices from a VMHA perspective. How do you add, or how do you tell VMHA, hey, I don't want you to ping the default gateway of the management network. Here's a list of IP addresses that you can use to determine if this host has failed or not. We talked about some general best practices on how to configure VMHA. Finally, I hope this lesson was informative for you, and I'd like to thank you for viewing.